In the previous lectures, we have seen that how to create a unique binary tree if its pre-order traversal and in-order traversal is given. This was the first case. Second, if its post-order traversal and in-order traversal is given. So in both the cases, we saw that we could create a unique binary tree. Now in this lecture, we will see that if the pre-order and post-order traversals of a binary tree is given, can we construct a unique binary tree using these two traversals? Okay. So now I'll just delete this part because we are going to focus only on creation of the binary tree. So let's see. Now, pre-order, we know what is the pre-order. Pre-order means first we are going to traverse the root, then the left and then the right subtree. Contrary to this, post-order is when we traverse the left subtree, then the right subtree and finally the root of the whole tree. So as per this, now how do we construct it? First, our first step is finding out the root. When in order, using the pre or the post order, we could find out the root. But here, since we do not have the in order traversal, what we'll have to do is, see, in pre order, the first node will always give you the root. Similarly, just a second, I'll just rewrite this. Pre-order means root, left, right. Post-order means left, right and root. Okay. So, in pre-order, the first node will be the root node. And in post-order, the last node will be the root node. And we can see here that F is the common node here. So this also verifies this fact. So we can say that F is going to be the root node of our binary tree. Now we need to find out the elements of the left and the right subtree. So now just try to understand this. When we are creating the, say we are finding the pre-order traversal of a binary tree. So after we have visited the root, we go to the left side of the tree, correct? So we go to the left side of the tree and we traverse the root first of the left subtree. So we can say that here B is the first root of the left subtree. Okay. So using this, now see, B is the root of the left subtree. Now when you look at the post order traversal, where is B? We have to find out B. So B is here. Now if you carefully look at this sequence, this says left, right and root. Now imagine that there is one node here. This is the left subtree. So it is something like this. And here we have the right subtree. Okay, I am not writing the elements. I am just telling you there are nodes. Now if we want to write its post order traversal, what happens? You go here, but we need to go to its left. So we go to the left, more left, and when we encounter the leaf, so we'll write this left, right and root. Okay. Once this left side finishes, then you go to the right side and follow the similar order. And at the end, you traverse this particular root. So, see, when you were traversing this, which is the last element that you traversed? It was this, which is the root of the left subtree. So, after you have visited all the nodes, say you had more nodes here, some more nodes here. So, after you have traversed all the nodes, all the elements of the left subtree, then only you will be able to visit the root node of the left subtree. Am I right here? So if you are having B here, what does that mean? It will mean that all the elements that we have traversed before B, they all will be the left subtree's elements. And the elements which are after B will be the elements of the right subtree. I hope I could make this thing clear here. So now this tree of mine, it becomes something like this. B is also here definitely, and H, I, G are the elements of the right subtree. Now we already know that B is the root of the left subtree. So it's like this here. Now we need to find out what about the left and the right subtree elements with respect to the node B. So for this, what we'll do is, we look at the element which is just next to B here, which is A. So we say all the elements before A will be the elements of the left subtree of B. But since there are no elements before A in the post order traversal, therefore I conclude that A must be here. Now let's see what are elements are left to the right of B. They are C, E and D. Now let's write C, E and D as per their sequence in the pre and the post order. So C, E and D, they are here. So in the pre order they have, the order is D, C, E, and in the post order the order is C, E, D. So here we can clearly see that D is the first element in the pre order and the last element in the post order. Therefore we conclude that D will be the next root. Now if you look at the pre-order, what does pre-order say? Root, left, right. So according to this, C can be the left child and E can be the right child. Now also if you look at the post order of CED, what does it say? Left, right root. So using both, we have verified it using both the orders. So we can write here like C and E as the right child of D. So we have completed the left subtree. Now going on to the right subtree. Now we will follow the same principle. For GIH, we'll write the sequence in the pre and the present in the post order traversal. So in the pre order it is G, I and H, and in the post order it is H, I and G. So G being common as the first element of pre order and as the last element of post order, we can say that G is the root element here. Correct? Now again following the same pattern what we have done here, that if this is root in pre-order, this can be the left and this can be the right child. And here H can be the left, right and root. But here if you see that in the pre-order, your left child, as per the pre-order, the left child must be I, the right child must be H, and it is different as per the post order. So therefore we conclude that we cannot use this particular method to determine I and H as the left and the right child. So what to do next? So we can see here that we have found out that G is the root node of the right subtree. Okay. So now we need to know the ordering of these two elements. So now we write down the pre and the post order sequence of IH and HI here. And here we can clearly see that I is the first element in the pre-order traversal and it is the last element in the post-order traversal. Okay. So what we can conclude here, that after G, what happens here after G? You don't have I and H as the left and right. Instead, both of them are the left child of G, like this. And from this particular place, you can understand that here I is going to be the root node. Now, tell me one thing. As you have found out that I is the root node, can you tell me that whether H should be the left or the right child? Same for here also. Can we determine? Let's see. If we put H as the left child here, then what comes out as the pre and the post order traversals? Can you tell me? It will be same as the given pre and the post order. So I think putting H as the left child will give you the same pre and the post order. So this was our way to verify. So we can say that this is the only binary tree we are going to get. Is it so? No. How? I'll tell you. If instead of putting H as the left child, I put it as the right child. Now find out the pre and the post order traversals of this particular binary tree which we have generated. You will see that they generate the same pre order and the post order traversals, which is pre order will be F, B, A, D, C, E, G, I, H, and post order will be A, C, E, D, B, H, I, G, and F. So thus we can conclude that we cannot make a unique binary tree using its pre and post order traversals. So to create a unique binary tree, the pre-order must be supported by the in-order traversal and the post-order must also be supported by the in-order traversal. So either you have a set of pre-order and an in-order traversal, or the set should be of post-order traversal supported by an in-order traversal. If you have the set as pre and post order traversals, you would not be able to create a unique binary tree. You will generate some binary tree. This is also a binary tree. But one may create this binary tree, other may create this binary tree. And also if you have carefully paid attention, in this part also, that is DCE, here also you could get different ordering of the nodes. Okay. So there arises ambiguity if you have only the pre and the post order traversals. But among the ambiguous options, you can select one option to create a binary tree. It will be a binary tree, but there will be multiple such possible binary trees. Therefore, creation of a unique binary tree cannot be guaranteed if you have only its pre and the post order traversal. It can be guaranteed only if the pre or the post order traversal is supported by its in order traversal. I hope I could make this point clear with this example. Thank you.